Hi, today I'm going to make a 3D scan of this tail light and I'm going to reverse it in the CAD software. So there's two ways that you can reverse the model into CAD. First is using a solid modeling and the second is using a surface modeling. Which one to choose is you need to consider it from the shape of the object that you are going to reverse. If the object has bidirectional curve, it means that it has two curvatures on both sides. I mean, it curves in one direction and it also curves in another direction. So this object should be reversed by using surface modeling. But if the object has a constant radius along the length of the object, it will be easier to do it with the solid modeling. Because of the surface that I'm going to 3D scan is translucent, so I need to use the spray to cover up the surface before start the 3D scan. So now we have a nice thin coat of the spray. It should be good enough for making a 3D scan. Next I will apply a marker on the surface. So I'm going to put the magnetic markers along the edges. And I'm going to put the sticker marker inside here, inside of the tail light. Okay, this should be enough to make a 3D scan. This will be the 3D scanner that I will use for scanning the tail light. Okay, here's the equipment that I need to do this scan. Scan Raptor X, a mobile phone, a gaming laptop. I have already connected the gaming laptop to the Wi-Fi handle, and also the phone is already connected to the Wi-Fi handle. So let's get started. Medium size object, I'll choose 0.3 for the resolution. Let's try one more time. Okay. I need to turn off the mobile network to get this to work. I'm using 34 lines laser mode to do the scan. The maximum spacing between the markers should be around 10 centimeters. Actually, it doesn't need a lot of markers at all. With Raptor X, it will take less than 1 minute to complete the scan. I think it's done. Next, I will copy the files and do the point cloud mapping on my desktop. This is scan software. I will try to remove the point cloud outside of the tail light. I use a pen tablet to do this because it's more precise. I'm not going to mesh this one, so I export the point cloud as ASC format and then I drop it into a cloud compare software. I change to the brighter green color so that I can see it clear. Then I click on the box section function and then I set the box thickness on the x-axis to 0.3 millimeters. So you can see that we have a very thin section lines of the point cloud. Next I will extract envelopes along the x-axis and I set the gap to 20 millimeters and the envelope type to lower. So I will get a section lines every 20 millimeters. Now the section line is created in a DXF format. It's a polyline, so I can use it in the Autodesk Inventor for creating the surface. Next, I do the same for the y-axis. Set a gap to 20 millimeters. Click on OK, and then I will have a section line along y-axis. Next, I click on the 3D line that I just created and export it. If you are using AutoCAD, you can just use the exported polyline from the Cloud Compare and start creating the surface by using patch surface command. But in this example, I do it in Autodesk Inventor, which is much faster and easier. Here in Autodesk Inventor, I will import the polyline that I create in Cloud Compare, and then I will use this to create arc lines in grid patterns. The pattern size is 2 by 2 centimeters, but I will use 4 by 4 centimeters so that it wouldn't be too many to draw, and this should be enough. This could take some time, depends on the detail you need to get, and I use the point clouds to compare the arc lines with the surface of the object. The point where there are sharp curve, I put the arc line closer together. Then I use patch command to create the surface by clicking on the boundary line along the edges of the patch. Then I turn on the point cloud and check the matching of the surface. Next, I will create a bottom surface by projecting the lines on the edge and create a bottom surface. And I also make 3D lines for creating the side surface. Now I have closed body surface so that I can create a solid by stitching the surface together, and I can send this to a CNC machine for creating a mold. If I use a smaller grid, the surface of the solid will be matched to the point cloud even more, but it will take a longer time to create. This process took me about an hour to do. If I want a flat pattern for cutting the acrylic sheet, for the forming process, I can use the unwrap command in the Autodesk Inventor to create a flat pattern of this tail light, which is on the right. And after forming, it will fit into the 3D curve of the tail light. And if I just want to 3D print the tail light, I will export as an OBJ file and do the modification in the Adobe Substance 3D modeler. I copy a part and make it a little bit smaller, and I use this clone part to subtract to the original part, and this will create a shell thickness because I only scan the outside of the shell. So this tail light has no thickness, but if I do the subtraction with a smaller clone of the body, then I can get the thickness of the shell like this, and this will take only 1 minute to do, and then I can export this model for 3D printing. But this is not a CAD format, so with a bit of smoothing work, then I can get the shell of the tail light with the thickness. Clay is still the fastest way to make a 3D print from a 3D scan. Okay, thanks you guys for watching. I'll see you in the next video.